Welcome to A-Level Physics. I am Miss Ellie, and you'll be seeing me a lot as we journey through learning physics together. But before we go into all the fun stuff, we need to agree on certain language that we use to describe the world around us. Physics is the study of things around us that we can see and measure. And that's why the very first chapter is just about physical quantities and units. So what are physical quantities? We need to agree what it is, okay? If we are to study it together. Physical quantities, basically you can say, this is not a formal definition, but this is something that can be measured. Can be measured. By the way, you can take down notes. You can follow along as I'm writing. Write down notes so you can keep track and keep your brain active as you're following along. But anyway, yes, we study the world by measuring it. So we create things called physical quantities, and you can, if you discover it first, you name it after yourself. Anyway, what else do we need to know about physical quantities? Every quantity must have two things. I'm going to write here, every quantity has what we say a numerical value. Oops, wow, I can't spell. Numerical value, like a number, and what we call a unit. And we'll learn more about what a unit numerical value is. But for now, just know that you must have value, must have unit. By the way, if you're still not sure what physical quantities in, here are some examples of what kind of quantities we are going to study together in physics. For example, we have energy. We have, what else we have? Power. We have density. Have you heard of some of these? Sound familiar? We have area. We have momentum. Very important one that we measure all the time is time. Exactly, time. What time is it now? Quite late, quite early. I don't know. We have a weight, which we measure things like our weight to keep track if we are healthy or not, how are we growing. But there's also mass, there's resistance, there's angle, there's so many quantities. I'm just going to put ... These are how we quantify the world. There are going to be two types that we're learning. Later, Miss Lee will be showing you the types of quantities, but there are two. One is called base quantities, and one type is called derived quantities. Two types. We're going to focus more on base quantities and base SI units specifically. So let's see, what are this one you got to memorize, okay? There's no loop around it. Base SI units, there are, I think, 7. The first one's very common is the quantity of length. How long is something? You take a ruler and you measure it. So the SI unit is meters. The symbol we use for meters is M. Other quantities, mass, we mentioned. This one is also a base quantity. Remember, this is base. Base. Everybody agreed that we'll keep this as our base. The SI unit is going to be kilogram. And we use the symbol kg. Okay, this one, hopefully you know. Time. What time is it? Time we measure. The SI unit is in seconds. Yes, there are minutes and hours, but that's not SI. Symbol for seconds, we use S. Everybody agreed? Next one, electric current. Electric current. You know, electricity is a pretty important field of study. Now, this one was discovered by a person called Ampere. I think, I don't know how to... It's a foreign name. I may have pronounced it wrongly. But the guy discovered it, so he can name it after himself. So, Ampere. Ampere. If you discover something, name it after yourself. Temperature. Another SI base unit. Temperature. This is in Kelvin. Why is it called Kelvin? Such a fancy name for temperature. That's because once upon a time, there was this dude called Lord Kelvin, and he did some very good work in temperature. So they chose his unit to be named after him. So Kelvin is a big K. There's Celsius and Fahrenheit and other kinds of temperature, but the base unit is Kelvin. SI unit. Okay, there's two more perhaps that we will learn a little bit more in A2. So all these friends here, these 5, are what we will see a lot in the AS, the first part of your A levels. The last 2 we'll see more in A2, the second part of your A levels. The very first one is the amount of substance. Let's say I have carbon. How much carbon? If I have oxygen, how much oxygen? If you take chemistry, you will see this a lot. It's a good friend. But we quantify amount of substance by moles, or the mole. The symbol for this that we often write is mole, just MOL. So like 3 mole. Can't see, my head's blocking. 3 mole of oxygen. What does that mean? That's just quantifying the substance. Then the last one, we have luminous intensity. How bright is something? How do we measure that? So last time, people's source of light, before they had light bulbs, they had candles. So they would look at the candle and they say, how should we quantify light? Use candle lah. Okay lah, we use candle lah. So hence the unit is candela. I mean, there's probably a nicer history to it, but I didn't go and find it. So the symbol we use for candela is CD to quantify brightness. So you need to know these physical quantities and you need to memorize the name of them, this one, because the past years can ask you, hey, tell me 3 physical quantities that are base quantities. So you need to be able to say at least a few. Okay, so that's quantities. Let's go and try exercise our brain a little bit to think about quantities. Here's one first question for us to look at. Here they are asking us, what is the approximate kinetic energy of an Olympic athlete when running at maximum speed during a 100-meter race? How are we supposed to know this? Is this a fact that we must memorize? Well, you see, physical quantities, right? We have to have a sense of estimation, guessing game, in other words. So let's calm down and think of, okay, what are we looking for? Kinetic energy. But remember, maybe once upon a time, we knew that kinetic energy was found with the equation half mv square, remember? Ooh, but we don't have much information here other than a 100-meter race. How are we supposed to know what is m, what is v? Maybe we can do some approximations. Okay, let's try to approximate v. Velocity, if you assume that there's no acceleration, that will be a distance over time. And this is a 100-meter race. We are looking at Olympic athletes. So maybe if you've never done this before, you can go and try Google a bit of stuff. And you see facts like, for the Olympic, the world record, I think currently is held by Usain Bolt. 9.63 seconds, that's about 10 seconds. So the fastest a human can run for 100 meters race is 10 seconds. So maybe we'll say, okay, let's say maybe it's 10 seconds, somewhere thereabout. So let's write here 10. So this will give me a speed of roughly 10 meters per second. The fastest human can run. Now, this is the first time you're seeing it. Write this down. The fastest a human can run. Maybe if you were an athlete in school before, you could calculate what was your personal record, your best, the fastest you can run. Get a stopwatch, run a distance, time yourself. Okay, we got V. What else we don't have? M. We need to estimate M. So an average athlete or average human mass is about 80 kg. Roughly, we get a mass of 80. I'm going to assume this is a average guy. Maybe a girl could be this heavy as well. Who knows? Somewhere around 80. 70 to 80. Can pick any value. Now we are good to plug in our half mv square. So now I'm going to say the kinetic energy, Ke, will be half mass. Make sure this is in SI unit. And v square, where is my velocity? 10 meters per second. So 80 times 10 squared. This is in meter per second. And pressing calculator later, you should get about 4,000. Did I get 4,000? Let me check my calculator again. 4,000 joules. That's a unit for energy. So 4,000 would be the best estimate. Now you may be suspicious and wondering about what about A? What about C? What about D? Try play around with the values. See if you use slightly different values, would you go very far from 4,000? The number of zeros matter. Speaking of the zeros, it sometimes is a bit troublesome to write too many zeros. Like this, like 4000000. That's a lot of zeros. So what people come up with is another way of writing out the zeros. We come up with this thing called prefixes to make our lives a little bit easier. So instead of having to write 1000000, 0, 0, 0. Oh my goodness, too many zeros. I can combine all these 0 into a prefix. I wonder which one it is. Let's look through if you don't remember them. The first prefix is Terra. Starts with a T. Please make sure you know your spelling, okay? Don't spell wrong in a homework or exam. And the multiplying factor is 1 times 10 to the 12. Giga is G. Have you ever heard of gigabytes? How much storage does your phone have? This one is times 10 to the 9. Next one, mega is a big M. This is 10 to the 6. Kilo, kilograms, kilometers, 10 to the 3. Deci, oh, this is where it starts to get a little bit foreign. Deci, we use D, not so common, but this is 10 to the negative 1. So you're getting smaller now. We scroll down some more. Centi is centimeter, cm. We use a C, and this is times 10 to the negative 2. Milli, millimeters for length as well. Milligrams sometimes. This is 10 to the negative 3. Micro is a mu. That curly thing is a mu shape. This is 10 to the negative 6. Nano, N for 9, 10 to the negative 9. And the last one, pico. I think we've gone all the way to 12. Okay, so this is 10 to the negative 12. Whew, that is a lot of... Okay, how do we use this thing? Remember just now I said writing a lot of zeros is a bit troublesome. How many zeros are here? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe I could write this as 0.1 times 10 to the 9. And this is a method of arranging a prefix because I say, okay, I start from here. My decimal point is supposed to be on the right, but I go 1, 2, 3, 4, 5, 6, 7, 8. There's no 8 in my list here. So I'm going to go to the next one, 9. So I go 9. And I put my decimal point now here. So that's how you can use this to simplify your life a little bit. Make sure you memorize the prefix name. Okay, at least not the name, but you recognize the symbol and of course the multiplying factor because you will need to do conversions throughout your entire A-levels. And if we need to be able to communicate the common way of writing out things. So one way of writing a physical quantity, let's write it out down here, is to use the symbol. So for example, let's say I like to measure the length of my phone. So you can take out a phone, try and measure what's the length. You know what a phone is, right? Phone, smartphone, see how long it is. And maybe I say, okay, the length of the phone, let's use the symbol L, big L. Okay. And I measure to be 12.3 centimeters in my ruler. This centimeters is going to be my unit. But not just a unit, it has a C stuck to it. This is the prefix. So the C and the M. And of course, your magnitude or your value is the 12.3 over here. Magnitude. This part. Okay. And what is this L here? This is what we call a symbol. Just a symbol that I choose to represent length. Another way you may write out the physical quantity is to use the multiplying factor, like one of these factors over here. So maybe instead of writing centimeter, I could change my mind and say, well, I think I want to write 12.3 times 10 to the negative 2 meters. So I just converted this C into its multiplying factor and I write it out. That's also fine. So there's few ways you can write out these things like this. And these prefixes, helpful in helping you to estimate values. We'll look at some estimations later. But first, let's practice converting. I'll tell you a shortcut that you can use in your calculator. So this question here is asking us, which time interval is the shortest? We have a problem here. We know the prefix. We just looked at it. Milli, nano. Okay, milli is 10 to the negative 3. Nano is 10 to the negative 9. And for nano, pico is negative 12. Mu is 10 negative 6. That one we know. But the difference is, if you look at the value, the magnitude, it's not very consistent. 2 decimal place, no decimal place, many extra zeros, and 1 decimal place. How? We need a standard form. So this is why we convert things into standard form. For example, I want to convert this into 5 times 10 to the something. Maybe I should do this first. The first thing is to recognize that I can move this decimal place by 2 spots. 1, 2. Move it over. That will give me a 5, but I need to include the negative 2. Then I include the milli, which is times 10, negative 3. Then next step, I combine the negative 2 and negative 3, and if they are multiplied together, I am adding together their powers. So this will give me a value of 5 times 10, negative 5. Very good. We can do this step for all the other A, B, C, D and compare. But important is now it's the standard form. We start with a 5. So grab your calculator. We're going to look at a shortcut right here. Your calculator may look a little bit different, but as long as it's a Casio model, one of the Casio 570 models, maybe it's a black color one, the more newer one, but it's okay. The newer one looks kind of like this. Ooh, can I see that? Right, so, but they generally have the same buttons, just different color. So what you're going to do is, let's do convert into standard form. 50, we're going to key that in right now. So 50. Then for prefix times 10 to the 9, I recommend that you use the built-in prefix button on the calculator itself. And you can see that it's going to be this button right on top of my head here, times 10 to the x. So we're going to hit times 10 to the negative 9. Hit the equal sign. If you get a fraction, stay calm. Hit the SD button. Somewhere around here where my mouse is hovering. Let's hit that. And it will convert it into a standard form. Nice for you. Hey, we already have 5 times 10 to the negative 8. So we're going to write here 5 times 10 negative 8. Done. Bless calculator. And we have the rest, so why don't we go through it? Let's go to the next one. 5, 0, 0, 0, 0, 0 times 10 negative 12. Hit equal. I get a fraction. I hit SD and I get my standard form right up there. Oh, beautiful. Let's try the next one. So this will be converted to 5 times 10 negative 7. Last one. Clear. 0.5 times 10 negative 6 equals to SD 5 times 10 negative 7. Done. So if I compare all of these, the smallest, shortest value will be times 10 negative 8. More negative, more decibels. So that's going to be B over here. One other thing I want to give you a heads up though is that this calculator will give it in standard form the first time you key it in, but you can change the prefix. How do you do that? Look carefully at your calculator. You should see a button that says ENG. I call it the ENG button right here. What does the ENG button do? Try hit it on your calculator. You will notice that this is 5 times 10 negative 7. If I hit ENG, it goes to 5 times 10 negative 9. Becomes more negative. But it goes to the nearest multiple of 3 lah. So this is converted to nano. Hit it again, it goes to pico. Hit it again, it goes to femto. I think this is femto. Hit it again, oh, negative 15 is the maximum we can go. What if you want to go backwards? You want to convert this to a unit of kiloseconds. Okay, sure, kiloseconds. What is this? Answer D in kiloseconds. You hit Shift and the ENG button, which is the engineering button. So Shift ENG, it goes to negative 12. Shift ENG, less negative. Shift ENG, less negative. Okay, Shift ENG, less negative. Shift ENG and Shift ENG. Oh man, oops. I hit too many buttons. Don't think I can go to... Yeah, I can't go any bigger. Maybe never mind. So if I want to convert this to the full no prefix form, this will be 0.0000005. Too many zeros. Okay, so play around with this until you're comfortable with ENG and Shift ENG. Be very helpful for you in your journey in A-level. Or I guess the other way is to make sure you know your indices and prefixes laws to know how to manually calculate it without your calculator. Okay, that's all for this question. So these quantities often help us to guess and make estimates, which is what this whole first part is about. This table shows some measurable quantities. Which row gives the correct order of magnitude of the measurable quantities in the correct unit? Wow, lots of things to check. Let's check. First one, mass of a coin. Haha, I've never measured a coin before, have you? If you don't know, you could maybe try to compare it to something that you do know. This magnitude 10 to the negative 4. How many? Okay, let's assume that this is 1 times 10 to the negative 4. So 1 times 10 negative 4, use the calculator skills, convert it to grams, will be about equivalent of 0.1 grams. That's really light. I don't know. Maybe it's correct, maybe it's not. I'm not very convinced, so I'll put a question mark here. Thickness of a sheet of paper. This is in 1 times 10 negative 2. So this is actually 1 cm, kind of equivalent. Is a paper that thick? 1 cm? Okay, we can use ruler and check. 1 cm is about this much. No, this is definitely out. Paper is not so thick. Wrong. Weight of an apple. 10 to the 0. 10 to the 0 is just 1. So 1 Newton. What is it in grams? For newtons, you gotta remember that weight is mass times gravity. So to find the mass, I think I will need to take that 1 Newton divided by 9.81 to find that. So 1 divided by 9.81. I'm going to convert that to grams with my calculator, and it's about 100 grams. Pretty accurate. I mean, this guy Newton had an apple hit his head, so I think that that's where he got the inspiration from, partially. Maybe. Okay, this one is likely. I like that. Temperature of a person's body. 10 Kelvin? 10 Kelvin? That's really, really, really cold. Really, really, really cold. Kelvin is a scale that is very, very different from Celsius. So 10 Kelvin, if you convert to Celsius, is about -263 Celsius. That's way, because 0 Kelvin is absolute the coldest, beyond freezing. So something's not quite right there, because for Celsius you need a plus 273 to get a Kelvin. So no, that's way too cold, not possible. That leaves us with A and C. I would bet my cents on C, because C is what I'm more certain of, whereas the coin seems a little too light for a coin. And yeah, you might be wondering, Miss, how on earth am I supposed to know all of this? Well, one way is to have a lot of hands-on experience on the world around you. If I ask you what's the mass of an orange, have you been to the supermarket? Have you bought orange before? You see I have orange here. You go and hold the orange in your hand and bounce it, measure it, put on the scale, follow your parents to the market, just, have a hands-on feel of how heavy things are, and then you compare with your phone. Is the orange heavier or is my phone heavier? Orange is heavier. So oranges and a lot of fruits, apples around this hand size is about 200-300 grams. So I guess you say for apples, oranges, what other fruits are that size? They're all about, where's my pen? All about maybe 100 if it's a really tiny orange, 200 grams. If it's a really, really big fruit, like your whole hand can fill, this might be 300 grams. Somewhere there. Definitely not 100 kg. See, something's wrong with the prefix? The prefix will give you a hint whether it's correct or not. This is just grams. Kg is like, whoa, that's heavier than a human. Not possible. No. Adult human, depending on whether you're a guy or a girl, you might have a very different range. So somewhere between, anywhere from let's say median, 60, 80, somewhere there. Also depends on which country you are from. Kg is what tells us. If you see something that says 60 to 80 micrograms for human, nah, the prefix is wrong. So the prefix should give you a sense of how heavy things are. Height of a room, go and measure the height of your room. I dare you. Take a wrong ruler, climb up to the ceiling, measure. It should be about 2 to 3 meters. Shouldn't be any taller or any shorter. Again, the prefix meter. No millimeter, no kilometer. That's way too long or too short. Diameter of a pencil. Grab a pencil, go and try and measure that. It's roughly about 0.5 to 1.0 cm. Yeah, go and measure your pencil. Lamppost. Go outside the road and try to measure the lamppost. I guess the lamppost is about... How do we draw this, man? Lamppost. Human. Maybe 2 human. Or maybe 3 human. Okay, 1 human I assume is 1 meter. So 3 humans maybe about roughly 3 meters. Depends on your country, depends on your location, but it should be in meters. That's the important part. Not kilometers, not millimeters. We stay in meters. Okay, so that's all for the first part. Make sure you know your units and how to estimate quantities and use your prefixes to help you with that. So that's all for this first video. We'll see you in the next one where we'll look at uncertainties, units, and scalars and vectors. Bye bye.